Hello, Professor Jinan. My name is Zhi Shen, second one, and my partner is Junjun Wu, the first one. So as you can see, this is the topic we chose and presented last time, and we make this video is aimed for to explain in a more clear way for those questions and for some code implementation. So as for the questions, we discussed on course about the content loss and the style loss. I'm very happy to explain it again. That um, for the concept of the style loss, um, I mean, the style loss is that to ensure the low-level features here of the generated image to match those of the style image. So here we use the early layers of the VGG network here, such as the layer 1.1, layer 2.1, layer 3.1. These early convolutional network to capture the local details like the colors, the colors distribution and the texture, and like some brush strokes of the style image. And for the style image itself, it passed through the early layers, as I said before, to extract its low-level features. And then we compare them with the corresponding feature from the generated image by calculating the similarity between these local features using the Gram matrix, the G here. And that can ensure that the generated image reflects the texture and the artistic details of the style image. So for example, if the style image is like a painting, it's like a Van Gogh painting or something else, we want the generated image to not only retain its structure of content image, but also to display like the painting distinctive brushstrokes and the color patterns itself. And for the content lost, for its higher level features, we're discussing what is its higher levels. It refers to the generated image that are similar to those content image. So in the higher level features, like those coming through, like the 4.2, 5.2 layer, representing the overall structure of the image, like the object shapes and layout, or the edges, etc. And we extract the same features from the generated image and compare them. So by minimizing the differences, we make sure that the generated image retains the overall shape and layout of the content image. So for example, if the content image is a face, is a portrait, we want to generate an image to still resemble the same person in terms of the shape and structure, even after applying the style. So to draw a conclusion that high-level features are extracted from the deeper layers here and represent the global structure of the image, and these are used for the content lost. And for low-level features, are extracted from the early layers here and capture the local details, like the colors and texture. Yes. And these are used for the style lost. So controlling the parameter for alpha and beta, we can adjust the balance between the content loss function and the style loss function to generate the final image and gradually improve the reflect both on the content and style. And for the next question we discuss is the Adam optimizer. And the Adam optimizer, why we are using them. At the very first time, we just uh, have some research on on the internet, and some people just use the optimizer, and we did really like forgot to how to figure out why the optimizer is the best choices. So later on, we did a little research, and find and there was some feedback about its fast and efficient, um, and it requiring less memory while processing. So actually, Adam optimizer is a better adaptive learning rate for it, like in the each pixel of the generated image. Adam help to speed up the coherence by automatically adjusting the steps size. And for next, I wanted to introduce a little bit more deeper about the results and the evaluation, because on the course I presented it so fast. So here is our next output. Okay, and the point is the evaluation. As I mentioned before, I we introduced the VGG, the very first the very first model, and then we find there's another model called the transformer version transformer, the VIT, and so we try to figure out like which one is like and which one is better, or how the VIT works, or even we combine them together and see how it happens. So then, according to the results, uh, we introduced some of the evaluation index. So first is in SSIN. Uh, yes. So it is refers to the structural similarity index, and this algorithm is used to calculate the similarity between the original image and the output image to compare the brightness and some later structural features. So VGG19 may lose the content details via style transfer, resulting its a lower SSIN, which is 0.72, and while VIT is 0.88. And for VGG and EIT combination, which was at 0.85. So while VIT uh, retains more image structure and hence higher than and hence a higher SSIN, the combination of the VIT and VGG take the advantage of the content and style to achieve the relatively high SSIN. So the higher SSIN, which means the better the content remain. So that's why we call it the evaluation of the content persuasion. So for the second evaluation index, we introduced the PSNR, the peak signal to noise ratio. Actually, in the image quality assessment, The PSNR is to measure the noise of an image. So a higher PSNR value indicates it with the less noise. So we, uh, according to evaluating the noise level in the image by calculating the PSNR between the original image and the generated image, it is shown that the VGG19 has a lower PSNR, and that's because it introduces more style details, which leads to more noise and artifacts. So when VIT has a better noise control, with a high PSNR, and then the combination of them achieves a balance between the two. And for the third one, the FID, which is also the point, and it is called a Fisher inception distance. So the FID scores indicate how close the generated image is to the style image. So the lower FID values mean better the style transfer quality. And it is calculated by the comparing the distribution of the features and that extracted from the generated image and the real image using a pre-trained model, a pre-trained network called Inception V3. Yes. So you can see here, actually, the combination of VIT and VGG has the lower index, so it is the best. And for next part, my teammates may given some implementation on the details of the code and show the results of our program, of our project. Thanks for listening and watching. Thank you very much. And I hope this and I hope this would explain it more clear.
We have a number of files, and this file is used to pre-train the VGG19 model. And this is the data. This is the data downloaded during training, and this file is used with pre-training the VIT models. And in these files, we use VGG19 models for style map. In this file, we have pre-trained the VIT models, and these 5 files are the model files saved for each training sessions for VIT. And this file, we use the hybrid of VGG19 and VIT models.